Okay, I think it looks like the numbers are still, some people still joining us, but let's get going so we don't leave ourselves too little time to get through this. Again, good morning, good afternoon, good evening. Thank you so much for putting this time aside to join us for this July TBC Power Hour, unlocking survey data. So today we will look at seamlessly integration with Esri ArcGIS features service using Trimble TBC's GIS module. So we will run through that today, show you all the good stuff that we've done. Myself, Albert Willifee, Technical Product Manager, been doing this for quite a bit now. And today I've got a new guest, Matt Morris. Matt, if you'll introduce yourself.
Sure. Thanks, Albert. Pleasure to be speaking with you all today. I'm a product manager in our geospatial or GIS business, specifically looking after a lot of our components that integrate between Trimble and Esri. I've been doing this a long time. I have an engineering background, both software engineering and civil engineering, and based here in Southern California. I'm also part of the team that maintains the Trimble Esri partnership. So could get involved in most things at that intersection between Trimble and Esri. And it's a pleasure to be speaking with you today.
Thanks so much, Matt. Appreciate it. Just a quick few housekeeping things. If you want to ask any questions, any comments, please use the Q&A interface window. You'll see down in your Zoom bar, you'll have a Q&A one. The chat we don't use as it doesn't get recorded. So please use the Q&A for any questions. That does get recorded with your email address. So if we don't get to all your questions at the end, which happens more often than not, we can always reach back out to you and answer those questions via email, or if there's any specific things that we need to get from you, we can always contact you that way. So please add your comments and questions in the Q&A section in the Zoom. Other than that, Matt, over to you. You can take over and run through this. I'll keep an eye on the Q&A, and at the end, we'll run through that and see where we are.
Thank you, Albert. All right. So today, what I want to do is, first of all, level set and make sure everyone has a baseline understanding of what is TBC GIS. Then get into some specific examples of workflows that can be used with it. Talk about key configuration items and what's important to know when you're setting up a project to use with TBC GIS. And then, as Albert mentioned, time for Q&A, and then also summary of resources available, including some new content that is relatively recently that we've made available specifically around TBC GIS. We've recognized that we haven't put out enough material about this. And this Power Hour, blog posts, web page posts, etc., are all trying to help push out more information into not only our distribution channel, but also our user community around how TBC GIS works and how it can benefit you in your workflows. Okay, so to start with, this isn't something that we built in a vacuum. This is something that was built through direct engagement with strategic customers. Okay, so over the years, we've heard about a need for this, and that's why we built it. It's why we continue to develop it. It's because we're getting direct feedback from customers in various segments. Basically, TBC GIS provides the functionality to connect directly to a GIS data source for the two-way exchange of schema and data. Now, we've always had the ability to export data, and you can send that file to someone to import it into a GIS, or we can import files that were sent to TBC from GIS, and those still exist. And in some cases, for kind of more disconnected project delivery, those import-export workflows do make sense. But for repetitive delivery of survey data into a common GIS, such as would be common for an in-house survey team for an organization, that can be repetitive and error-prone, right? You're exporting to a format, you may lose some fidelity of data if you export to shapefile or something like that, and then you're sending that to someone else who has to then import it. Well, what TBC GIS does is allows you to connect directly from TBC to that GIS data source and just repetitively push, as you survey data, as you complete work, just push that into the GIS, read data back in, data flows back and forth. You can pick up updates that were made in GIS back in TBC, etc. Like I said, TBC GIS reads and writes both GIS schema, so that's the structure of the data, as well as the features themselves. In TBC, anything that is collected, say in Trimble Access, process. So you baseline processed it, you feature code processed it in TBC, or extract it as a feature. Let's say you did some mobile mapping data or some scan data, and you've extracted those features according to a feature code library. All of those types of features, points, lines, and polygons can be written to GIS and used in the GIS module. In terms of bringing GIS data into TBC, you have the ability to define that by area, by a window, by a polygon, and also use attribute queries. So to say, let's say I want to bring in data from my utility layer and I only want to bring in pipes above a certain size, I can specify all that through an attribute query. TBC GIS is included as an optional installation component and is included in various subscription and perpetual bundles or as an add-on. So I mentioned that TBC GIS provides this direct connection to GIS data sources. Well, what kinds of GIS data sources? And really these fall into two categories. There's kind of more the Esri ArcGIS data sources, and then there's traditional database sources. So the first ones I'll talk about are the right here, the PostgreSQL, Microsoft SQL Server databases. So these would be, I have a database that has spatial information in the database, and I want to bring that into TBC, or I want to send TBC process data into a Postgres database or a Microsoft SQL Server database, and I have columns there that store my geometry. So those data sources are supported. What we're here to talk about today is specifically on the Esri side, on the ArcGIS side. Two types of data sources we support. We've long supported geodatabases in the GIS module, the ability to connect to an enterprise geodatabase, including support for versioning, or file geodatabase. And if you were to use that part of the GIS module, it does require co-installation and licensing of ArcGIS Pro or ArcGIS Desktop on the computer with TBC. But the newest one that we've had now for a couple of years is this ability to connect directly to ArcGIS feature services that are hosted in ArcGIS Online or ArcGIS Enterprise. I'll get into ArcGIS feature services a little bit more on the next couple slides, but I do want to point out at this point that this requires no additional licensing on the desktop when you connect to a feature service from TBC. We've included the Esri SDK surface that's doing that connection, and the only requirement is that you be assigned an appropriate user type through your primary ArcGIS licensing portal. So that would be your ArcGIS Online, your ArcGIS Enterprise, and that's how you get access to it. So as long as you have a user type in your ArcGIS environment that allows you access to those services, whether you can read, write, whatever, that's all that's required. There's no additional licensing to use this in TBC. And there's no additional installation components because we include that Esri SDK, those Esri SDK components inside of the TBC installer. Okay, it's no secret that I think a lot of people consider GIS a system of record, and a system of record that can enable and be shared with other enterprise systems in an organization. At the end of the day, GIS helps to bring together project and site-based data across space and time. A lot of times survey work is based on a site or a project, and what GIS is really good at is bringing that together from different time periods, from different spaces, being able to contextualize that then with other spatial and non-spatial data. So, you might have other layers, other environmental layers in your GIS, you might have other political boundary layers, and all that can be contextualized in GIS along with your project-based survey data. GIS enables use of a consistent authoritative schema for assets across survey and GIS workflows for optimal data quality. For example, in an organization, in a water utility organization, you may want to say a hydrant has these properties that define a hydrant, right? And these rules. These properties are required, these properties are optional, these properties can only have to be one of these values, like a pick list. Well, I want to enforce that rule or that model for my asset across any workflow. So if I'm entering it in GIS, if I have someone doing an inspection out in the field, if I have someone as a surveyor out using Trimble Access, I want to use that same data model regardless of workflow. GIS also implements a common database between asset capture workflows, such as what we build in Trimble Field Systems and Trimble Geospatial, and asset lifecycle management solutions, such as Trimble Unity over in our OMPS side of the business. So GIS is that common layer between these two types of systems. Okay, getting into Esri ArcGIS specifically, which is, is in the title of the webinar. So I hope you came here expecting to hear something about Esri ArcGIS specifically. It's not the only GIS system of record, but arguably it's the biggest. TBC GIS supports the primary Esri ArcGIS data sources used by customers, geodatabases, and increasingly feature services. For the last maybe 5+ years, it's become very clear in the Esri customer base that feature services are the preferred integration pattern for the modern Esri customer. They are supported at a core level across the ArcGIS platform. ArcGIS feature services can be hosted in either ArcGIS Online or ArcGIS Enterprise. So you may hear ArcGIS Enterprise referred to as Portal. Portal is the kind of cataloging discovery user experience on top of ArcGIS Enterprise. And basically, if you're wondering, well, I'm not an Esri person, but what's the difference between ArcGIS Online and ArcGIS Enterprise? ArcGIS Online is a SaaS offering. You pay a subscription, or it's included in your Esri license, and you get access to it. It's hosted by Esri. ArcGIS Enterprise is most of that same functionality, but you host it yourself, either on-prem, in private cloud environment, et cetera. So that's your own, you bought the software, you license the software, and you're hosting it yourself. Feature services expose GIS content to distributed clients through RESTful web services. This is a much more performant, scalable model than the old. Some of us who've been at Esri a long time used to, we connect to an ArcSDE database, right? An ArcSDE geodatabase. And if you try to do that over a VPN connection or over a wide area network, it was super slow because there was a lot of latency, very sensitive to latency. Well, feature services deal with all that because it's a RESTful web service. It's architected for that reason, scales much better, much more performant over all different sorts of network connections. I do want to point out from a nomenclature standpoint that ArcGIS feature services are similar to, but not the same as OGC web feature services or WFS, nor are they the same as OGC API features or OGC features API. We've been a little bit loose in our nomenclature at Trimble. We're trying to be more standardized on that. And when we're talking about OGC feature services, we say OGC web feature services. When we're talking about ArcGIS feature services, we put ArcGIS in front of it. In general, ArcGIS feature services are referenced and used via URL, right? It's a URL with an HTTP link, server name, the service name, and ends in feature service. At the end of the day, Trimble support for feature services, not just in TBC, but also in our GIS products, such as Terra Office, enables Trimble's survey and GIS workflows to live alongside core ArcGIS workflows in a single customer environment. So it's giving users the ability to use the right tool at the right time. Okay, let's talk in workflows. Before I talk about 3 specific workflows, I want to point out that all of these workflows in TBC GIS involve the same basic steps. And those same basic steps are, on the GIS toolbar, you will use the GIS connection manager to create a connection to a GIS data set. And that's where you'll put in your feature service URL. To read existing GIS features into TBC, you will use the read features from GIS tool, right? So it's pretty self-explanatory. That pulls data into GIS. To write processed or extracted TBC features back into GIS, you use the write features to GIS tool. If you are writing features, maybe you've read features in, you've made changes, you want to write features back out, the existing features in GIS will be updated. We store those relationships. When you pull features in, we relate the feature in TBC to that ArcGIS feature, such that when you edit it and want to write the changes back out, we will update that feature in GIS and we will not duplicate it. Lastly, if all you want to do is, maybe at this phase of the work, you want to create a new feature code library from GIS, you will use the Get GIS schema tool. And you'll see examples of this very shortly. Okay, 3 example workflows. I'm going to run through these demos first and then provide some more details afterwards, because I want to show you the end result, and then we can talk about how I got there. So in each of these cases, I recorded these videos yesterday using the released version of TBC 2025.10. Most of this functionality, except for the last one, most of this functionality has been there for a couple of years, so it's nothing, groundbreakingly new. And I'm using the latest version of ArcGIS Pro, and I'm using services on the latest version of ArcGIS Online. Okay, first example workflow is water utility GIS data, bringing it into TBC for design context. So as a water utility, I might want to, I have all of my layers in GIS, and I want to bring some of those infrastructure layers into TBC for context during a road design or some other project I need to do to see, well, let's bring in those layers so I know what I'm starting with in a certain area. Additionally, I may want to bring those features in and send them out to the field in a job in Trimble Access because I need them staked where there's buried infrastructure, right? So that's the workflow that I'm going to, that would be a use case for bringing water utility GIS data into TBC. The second demo is a topo survey, right? We all kind of know what that is, but it's a topo survey from TBC that I want to send to GIS for storing all my as-built. So after I've completed building something, I'll go out and I'll do a topo survey, collect that as-built, and I want to send it into GIS, which I use to pull together all of my different sites and project work. So this was data, let's say this was data collected in Trimble Accessed, feature code processed, or baseline processing in TBC, and I'm going to send that into GIS as an as-built repository. And lastly, the third workflow will be TBC feature extraction to GIS for pavement condition inspection. So TBC can be used with mobile mapping, point cloud, and imagery data to extract, using an AI engine to extract pavement condition defects. And I want to be able to send that into GIS for further analysis or planning the repair work. So this specific functionality around being able to have the PCI data participate in a GIS connection, that is new in 2025.10. But any other feature extraction, all other feature extraction workflows based on, that has always been available in TBC GIS. Okay, first one, water utility data. Let's do this. Okay, hope that you can see my my screen here. So here I have my water utility data in ArcGIS Pro. This is something that is very common for a water utility, and I'm going to zoom in and see that this is the area I'm interested in, okay? And as I zoom in, layers turn on, I see some water mains, I see some laterals, I see hydrants, I see shutoff valves, I see meters, I see service lines. So this is the project area. I'm going to be doing some road work in this area, and I want to bring all this into GIS. So the first thing I'm going to do is go in and discover that feature service URL. In this case, I'm pulling this out of a property of the layer in ArcGIS Pro. There's my URL. I'm also looking at my coordinate system. So I'm verifying that, this is Illinois State Plane NAT 83-2011. So I have the EPSG code 6455. So I'm going to come over into TBC, and we're going to start a new project in TBC. So this example will start with a project from scratch. And what I'm going to do is create that new project, and I'm going to do two things when I create the project. I'm going to first define the coordinate system for the project. And so that was why I wanted to check that in GIS. So here I will pick, I'll search for that EPSG code 6455. And I'll talk about coordinate systems a little bit more after these workflow demos. The other thing I'm going to do is I am going to set my feature code library. Now, what I have done already is I have created a feature code library for this GIS data. And I'll, again, talk specifically about how I did this. For this demo, you'll see that I've already created that. So now I have a new project. I have my coordinate system. I have my feature code library that I'd already created and symbolized, okay? And now what I'm going to do is I'm going to go zoom into that area where I want to bring that data in. And I'm going to use the functionality in TBC to limit what I bring in. So I'm going to go specifically to the area of Naperville, Illinois, where my utility is, and I'm going to go into that area, and I'm going to start using the GIS module in order to get that data in. I did specify geoid 18. Maybe I didn't show it, but I did click through that relatively quickly. So this is Illinois State Plane NAT 83-2011. And using geoid 18 for orthometric heights. So here's that same area, right? And I've turned on my base map from Trimble maps just to see that same context, to know where I'm looking at. So I'm going to go to the GIS connection, pick Esri service, paste it in my URL. And here, as I mentioned, I'm prompted for my ArcGIS authentication. So my login gives me the ability, if I knew how to type my password, gives me the ability to read and write to these data sources, okay? So I'm going to go ahead and connect to that. And now I have a connection to this GIS data source. Now I can read features. And what it's already taken care of in the background is mapping the coordinate systems, saying that, hey, you're using the same coordinate systems on both sides. So here I see a summary of the data that's available to me, and that's a lot of features over in that total column. But what I'm going to do is only bring in the features within this polygon, because that's all I'm interested in. So I'm going to click OK. And then what this is going to do is it's going to go apply that filter, that spatial filter, when reading data from these feature services across those 5 layers: hydrants, lateral lines, mains, service connections, and valves. So if I were to try reading in the whole thing, TBC feature services have a limit on what you can read in one shot, so I wouldn't be able to bring all that in one go. But in this case, since all I'm interested in is a specific area, works pretty well. So here I have 421 features came in, and here I have those features. And like I said, I've already symbolized them through my feature code library to look something like they do in GIS. Symbology is something that doesn't come out of the box. You're kind of on your own with symbology to try to make GIS and more CAD style symbology match. And here I see not only my geometries, but all of my attribution as it existed in GIS. So now I have this available to me contextually for my for the work I'm going to do, this design project. And like I said, I can send it out to the field in an access job if I want to go have something staked out in the field. Okay. Workflow 2. In this case, we talked about a topographical survey that I did, say, in Trimble Access. I went out, collected a bunch of features with the feature code library that I authored in Trimble, and I want to then send that into GIS. As I complete an as-built survey of a site, I want to be able to send that into GIS, and then I want my GIS users to have access to that data for all of the sites that I've surveyed. So let's go ahead and start there. So what you see here, it's a little blurry at first, but it'll click in. So I have on the left, I have a project in TBC. On the right, I have an empty screen in ArcGIS Pro, and this is a feature service. So I'm just showing that, hey, no data exists yet for this location. So this happens to be a rest stop, and I'm going to do the same thing. This ArcGIS Pro project is already referencing that feature service. So I'm going to, same thing I did before, get that URL because that's what I need in TBC. I'm also going to validate the coordinate system. This is another NAD 83-2011 state plane. This happens to be California Zone 2 up in Northern California. So here I have, fairly traditional TBC project. I have a fairly comprehensive feature code library that was authored in Trimble tools, right, using Feature Definition Manager. And I can click on things. That's a tree. I see some attributes and properties of the tree there on the left in the TBC properties window. And I've, a fairly traditional topographic survey. I have control points. Again, not heavy attribution, but attribution nonetheless, and the ability to attach photos and files as media elements based on my feature code library. So remember those steps. First step, create a new connection. I will give it a name. I will pick the data source type, Esri service. Connect. I'll paste in that URL that I discovered earlier through ArcGIS Pro. And again, prompted for my login. And I should mention that in this particular demo, I'm getting that feature service URL out of ArcGIS Pro. In a later demo, I'll show you I can also get that through an ArcGIS Online web environment or through the web user interface. It doesn't have to be ArcGIS Pro. So here, when I connect, now what I'm doing is I'm going to write features to GIS. So you see here on the right, these are all of the layers in my GIS connection that I can write data to. And it's already been mapped to my feature code library. So all I'm doing here is I'm selecting all the features, and I see the counts there in that new column saying these are all new features that I'm going to write into this GIS data source. Now, I want to point out that the number you see at the top, that selected data to right says 1976. That includes all of the individual points that make up lines. And that is not data that will get sent over to GIS. From a line and polygon standpoint, what ends up in GIS is the finished geometry. Although what we retain in TBC is that those constructions, all those individual points make up the line, make up the polygon. But what gets sent to GIS are points and the finished lines and the finished polygons. So you'll see in this report when it's done, that resulted in 374 features being sent to GIS. So now let's flip over to ArcGIS Pro, back where it's referencing that feature service. I'm going to refresh it, and I'll see that there is that data now in ArcGIS Pro. I'm using ArcGIS Pro to look at a feature service, and I've already defined my symbology to match roughly what exists in TBC. And I can click on a feature and view properties. In this case, I happen to click on, I selected a feature instead of, and so I'm going to get a property here of a base layer that is irrelevant. So district tiger lines is completely separate. But when I click on, I'll clear that selection here, and then I'll click on, for example, the tree, one of the trees I clicked on earlier, there's the properties of that tree. And this is now a two-way connection to this data. If I edit an attribute of this in GIS, I can read those changes back in TBC. If that someone put in that tree information wrong, or someone in GIS wants to provide additional attribution, I can read that back in TBC to my existing project and the existing feature. Here's a sign, traffic control, regulatory sign made out of metal. So there's my data sitting in that feature service. Well, what does that look like through a web browser, right? Because a lot of GIS users, if they're using ArcGIS, are going to be accessing this content through a web browser. So here I'm logged into ArcGIS Online. I'm looking at my content, and I want to go down. And I want to only look at web maps. A web map basically references layers, references feature services. So here I have that same feature service that I was using in ArcGIS Pro. Now I'm referencing it in a pure web-based web map. And here I can contextualize it with my district boundaries, with my state plane zone boundaries. And this is where maybe this is more, could be a project index where I could say, hey, well, this is, my starting point for looking at my survey data across a bunch of different projects. So sure enough, I can zoom in, see the exact same content rendered the same way cartographically. And I can still click on things and get a pop-up to say what that feature is. Same functionality. I'm just showing it here in the browser. And this is kind of the power of GIS, is being able to spread this, provide access to this data across a lot of different clients, mobile clients, web clients, desktop clients, etc. You also have the ability, obviously, to set bookmarks, things like that. So I can go back to that context of my districts and zones. Okay, so last workflow is specifically is around feature extraction. So in this case, what the starting point here is I have mobile mapping data, and I have run an AI engine on it to extract pavement defects. So this is functionality that existed in TBC, but what's new here at 2025.10 is the ability for this data to flow through the GIS module. The constraint is you have to have a known schema in the GIS that matches this PCI. And there are some ways you can manage that if there are some differences in naming. But I can click on these. I've extracted alligator cracking. Here's one that's rutting, high severity. So all this comes out of that pavement condition inspection work in TBC. So now I have this data, and I want to bring this data into GIS because I want to contextualize it with maybe some other layers for, is this near open space? Is this near other environmental concerns? Is there anything around the work planning I need to be aware of for repairing these defects? So I'm going to do this through a web browser exclusively. So I'm going to look here and look for my layers that I've already created to store this data. So here I'm looking for feature layers. So I'm using the filtering tools in the environment here and find this layer that I'm looking for. So here's the layer I've created with the appropriate schema, and I will discover the URL from here. So there is that feature service URL that I'm looking for, that I need in TBC. So let's come back to TBC. We know what we need to connect to. We know where we want to send this data. Create a new connection. ArcGIS Online, call it AGOL, call it anything you want. I should point out that a TBC project can be connected. You can have multiple connections. If you have you want to bring in other sort of layers from other GIS data sources, you can do that. Now, what's interesting here is when I connect to this data source, it's saying, hey, I can't resolve these two coordinate system differences. What do you want me to do? And you get the choices of change the project coordinate system to match GIS, keep them, but perform a transformation between the two, or consider them to be the same. You also get specific control over what type of elevations are coming in from the GIS, orthometric or ellipsoidal. So let's go in and go back. I'm going to cancel that. Let's go look at this project and see why this is the case. Well, sure enough, here's what it is. We see that this project in TBC was created in WGS 84 for whatever reason. So what that tells us is that what we need to do is actually select that middle radio button here that says transform grid coordinates when reading and writing features to and from GIS. So navigate between a WGS 84 project in TBC and a zone or a projected coordinate system in GIS. So now I have my connection. I'm going to select all the features that I want, and I see them selected here in those 5 layers. And I use the right features, right? This is right features to GIS. Selected all the features, and I'm going to send those back over. So now all that pavement condition, all that data that extracted, the condition scores, all those individual defects now have been sent to GIS. I am showing here that after every write operation, we give you the ability to look at a report. So you can see success, failures, etc., to give some more information about what just happened and if it worked the way you expected it to. So I'm going to take that, go back to my ArcGIS Online user experience, and I'm going to add that layer to a new map, right? So what I've done here is I have just opened up that layer in a new map. So this is just the default map, and I can zoom in and see that data now, that feature service data layered on a default base map, right? And so, okay, I'm part of the way there now. But what I want to do is, first of all, look and make sure that I have all my, so the whole, what I did ahead of time is I did set up all the symbology here to match in TBC. Again, symbology is kind of a, manual, you got to do that yourself. It's not included, not really supported. We don't set symbology automatically. I'm going to change the background map here to be maybe easier to visualize over an aerial photo. And what I talked about with GIS is I want to contextualize this data. So what I do, I know that there are layers available in ArcGIS Online that are public, or in ArcGIS's Esri's Living Atlas that might help me contextualize this data. So the first thing I'm going to do is I'm going to look for a layer in a Jefferson County kind of open space layer, or non-Jefferson County. What's defined as open space land that is so I can add that layer. So let's add, I know I have open space designated land around here. Let's add a layer and see what that is and see if this project site is anywhere near that. And I say, okay, it's not immediately adjacent to, but it is within range of, there are kind of open spaces around it, which might inform how I need to perform this from an environmental sensitivity standpoint. Additionally, what I can do is I'm going to say, some of these in this aerial photo, I see things that look like schools. When I'm doing work in this area, do I need to be concerned about schools? So here I'm going to go over to the Living Atlas, and I'm going to just search for schools. And you saw earlier that I had already picked a filter for results in the map area. So I just added a layer for public schools. And sure enough, there is a school here. And I can click on it and get more information about it and see that it is a K-8 school. Maybe this will inform when I can do this work, because K-8 schools typically are out during the summer, so less traffic on the road, easier to do repairs on the road. At any time, I can go look at map symbology and see all these layers that I've added, not just my pavement condition inspection that I, again, pushed from TBC and all of its detail, but also all these other layers that I added for context. If I want to go in and keep changing base maps, there's a lot of other base map options available in the context of GIS to help me visualize this data. Okay, so those are the 3 workflows. And in those workflows, you see that I already had some things set up, right? And some of that is just to make sure the demos flow clearly. But now is the time I want to talk specifically about those key configuration items and how do you get to those workflows. There are 2 big things, and that is schema and coordinate systems. The best practice is to make sure that these match between TBC and GIS. So in the TBC side, a schema is defined through a feature library that controls attribution and symbology for each feature type. In TBC, a feature is a point, line, or polygon that has been assigned a feature type from a feature library. GIS is all about schemas, right? You have each layer is, the layer defines the schema, the types of attributes, the data types, the rules, whether it's required, whether it's a min and max value, choice lists, things like that. And the GIS module translates between a GIS schema and a TBC schema. But what it doesn't allow you to do is map between disparate schemas, right? So you need to have those set to match. And I'll talk about that on the next slide. Additionally, coordinate systems. You saw me do this in the demos where I was validating coordinate systems were the same. In TBC, the project coordinate system defines the spatial reference and includes a horizontal component and a vertical component. The horizontal being zone, datum, and transformation, vertical being the geode. Esri also has its coordinate system definition. Now, you do have some ability to navigate between differences in coordinate systems, as we saw in that last demo, but where possible, you want to have these be the same. So let's talk first about schema. TBC GIS expects the schemas to generally match. And really, that means you need to decide which schema is authoritative. Are you starting with a TBC schema that's authoritative, or are you starting with a GIS schema that's authoritative? If it's a TBC schema, you'll want to create a GIS schema from it. You'll use TBC to export that entire feature code library to a geodatabase XML file, and then you'll use ArcGIS tools to create a geodatabase and feature service from it. And I have a video that shows that. If, on the other hand, GIS is your authoritative data source, you'll want to create a TBC schema or a feature code library from it, right? So in that case, you'll use the Get GIS schema tool to create a feature code library from that GIS schema. Symbology, like I mentioned, you're generally on your own with trying to craft symbology that matches. There's not a lot of great tools for taking a GIS symbology and representing it in TBC or CAD, nor is there great tools for going in the opposite direction because the symbology models are really entirely different. So let's take a look at this. So in this video, I showed two things. The first thing I'm going to start with is I have an authoritative schema in TBC. For this demo, I'm actually using the global features feature code library that ships with TBC. So I've created a simple project in the coordinate system 6424, which is my local California state plain zone. And I see that here are my feature types in that global features FXL that ships with TBC. I can use this in Trimble Access, whatever. And I can go in here, I can look at it and say, yes, this is my authoritative schema. I've defined it using Trimble tools, and I want to bring that schema into GIS such that I can connect to it. And now I can send data from TBC to GIS and the schemas match. So how do I do that? Well, I go over to the traditional export, right? We talked about there's still use cases for this. I will pick the GIS format, I'll pick the geodatabase XML exporter, and then I'll specify these specific options at the bottom. Export all feature definitions, export feature library schema only, merge domain lists where possible, and create attachments. Now, what create attachments is if you have feature types with attributes that let you store files. So that could be a file or photo attribute type. What this means is that we will, when we export this geodatabase XML file, which is a definition of an ArcGIS schema, we will enable those layers for attachments because we want you to be able to store those files that maybe you've associated with features or captured in the field in Access or added to the features in TBC. We want to be able to pull those files into the GIS as well, pictures, PDFs, etc. Okay, so now I'm going to export this and it's going to go to this geodatabase XML file. So this functionality is not new. What is new here in the last couple of versions is the ability to export all feature definitions and no data, right? I just want the feature definitions. I don't want the, I messed up. I don't want the data. I don't want the data. I just want the schema. Okay, so that's what I just did. I exported just that schema. I didn't want any data, just a schema, and I want every layer in my feature code library. Now I'm going to flip over to ArcGIS, and this is a default empty ArcGIS Pro project. I'm going to create a new file geodatabase, just an empty geodatabase. This is the process you need to use, and I'm going to call it global features WGS84. The reason I'm calling it WGS84 will be clear to you in a minute. So this is just an empty geodatabase, file geodatabase, and I'm going to import that geodatabase XML file that I just exported in TBC. So I picked that one. There's that XML file, again, based on that Trimble global feature code library. And I see that here's all the layers, the feature classes, and the attachment classes The reason the item count jumped here to 225 is because when you enable feature classes for attachments, it adds multiple other data structures in the geodatabase. That's why it's 225 instead of the 112 that we saw over in TBC when we exported that feature code library. Okay, so what this is doing is this is building out the geodatabase schema. This is the process you need to use to do it. So now I have an empty geodatabase with all that data. Now, when I go look at the properties of these layers, I will see that they are WGIS84. But I don't want my GIS data set up in WGIS84. I want it set up in a local coordinate system, a projected coordinate system. So I'm going to create a new empty geodatabase called Global Feature 6424, indicating that that's the schema I want to schema here that is using an appropriate coordinate system. And I'm going to look for an Esri geoprocessing tool called Batch Project. And what Batch Project does, it allows me to say, I want to take all these feature classes and I want to copy them over here in a different coordinate system. And if there's data in it, I want it to be projected. Now, in this case, these are empty. So there's no data to project, but I want the properties set up correctly. So here I picked 9, 10 layers and from that original one, and I picked my output. I want them to go into the 6424. And you just saw me there. I picked the, I don't know if you can see what I just did there, but I basically searched for 6424 and said, hey, I want you to set up this new schema specifically in this state plane zone. So 6424, and I've done that. So now I hit run, and it's basically going to set me up with a these 10 layers. Feature classes are going to exist in that new geodatabase in the coordinate system that I want. So this is now my schema. This goes through fairly quickly because I only included 10 layers. If I had done the entire 112, it would have taken longer here. So now I have, if I go back to my catalog, I'll see that in that 6424 global features, I have the layers I want. This is the schema I want. And we're talking about feature services. So I want to publish this to a feature service such that I then can connect to it from TBC. Now, if all I would cared about was the geodatabase, I already have it. But it is the first step. It's a prerequisite towards creating a feature service in a specific coordinate system in this workflow. So I've added those layers to a new map. I'm going to go in here and see that my map projected correctly to my local state plane zone. I see the orientation. I will check it just to make sure that my coordinate systems are set correctly in my map. Yes, there's my XY and there's my transformation. The reason the transformation is there is for the base map. The base map, Esri base maps are always WGIS84 Web Mercator. So now I'm going to give this map a name. This name will form the basis for my feature service name. So this is all Esri functionality, right? But I'm just wanting to show you the end-to-end workflow from how to get to TBC, schema and TBC to schema usable, GIS schema back usable in TBC. So what I'm doing now is I'm using ArcGIS Pro's sharing functionality to share this map as a feature service. So this is what this looks like. Shared as, it's called sharing it as a web layer. Layer type is feature. This is the workflow I would use to do it. So I started with a geodatabase XML and then got into, brought that into a geodatabase, published it as a feature service that then I can use in TBC. So let's go back, flip gears. What if my Esri schema, my ArcGIS schema is authoritative? So let's go back to this example earlier of this water utility. Here, very much so, this was a water utility data model authored in Esri originally, and I want to use this. I want to create a feature service from, I want to create a feature code library from this. You saw me, I already had this. When I did this demo, I already had a feature code library. So how did I create that feature code library? Well, let's go back to this project where I have a connection to this feature service. Here, I'm going to use the Get GIS Schema tool. And here I see it's already gone in and said, here's the schema. You have these 5 layers. Here's all the attributes in those layers. Here's the data types, whether they're list, whether they're, double, date time, et cetera, their default values, whatever. So it's going to read all of that Esri schema that is directly translatable to a feature code library. And I'm going to create a new feature code library from it. And here's the result of that. I have the 5 layers, 3-point layers, 2 line layers, and I can look at hydrants here and see those attributes, see that they've already been converted to the right data type. If it's a pick list, I will see those lists. So these, again, this was all defined in the Esri side. Now what I'm doing is I'm creating a Trimble representation of that schema that matches. So now I can use this, I can go survey this data and know that it will match my GIS schema. The other thing I did is I defined symbology, right? When you create a default feature code library using get GIS schema, you're just going to get default symbology. So I did go in using feature definition manager, and I did define symbology to look more like the GIS. Make the pipes blue, make the hydrants red, make the valves with the circle with a cross symbol, etc. That was manual work I had to do at the feature code library level. Okay. Coordinate systems is a topic that could take up a whole hour, as we know, especially anyone who knows me knows this is probably something I spend 15–20% of my time in around coordinate systems, and specifically around coordinate system interoperability. So I'm not going to dive into a lot here other than to say Trimble and Esri ArcGIS products model coordinate systems differently. And the entries that you see in TBC and Esri may look more different than they actually are. The models are different, the nomenclature is different. If possible, try to use standard, quote unquote, EPSG coordinate systems if possible, and the code, so those WKIDs, which you saw me use, I did 6424, I think I did 6455, are a generally safe way to determine coordinate system matches between Trimble and Esri, except when they're not, right? Certainly, you have some free-form ability to specify a WKID that may not be correct. But in general, for using the GIS module, your best bet is to have these coordinate systems match. And certainly the WKID can be a useful tool in doing that. Both Trimble and Esri provide a lot more documentation, a lot more information through either Trimble's coordinate system manager, through Esri's documentation. They have a GitHub repo, which explains all their coordinate systems, and you can go get all the nitty-gritty details you want to make sure that they're the same. But we've been really making a concerted effort that when we say in Trimble, if it's aliased to EPSG 6424, then you are going to get that coordinate system, and it'll be the same as Esri's 6424, as EPSG 6424, etc. So that's what we're really focused on at an interoperability level, is making it easier for you to determine those coordinate system matches. Okay, a few other bits and bobs. I'm running out of time here, but a few other things I just want to mention. Metadata. You saw in the toolbar, the map metadata tool can be used to map some GNSS metadata, and that's typically from RTK vectors or total station observations to GIS attributes. Metadata mapping between that property in TBC and the GIS attribute is generally assigned per layer. And those attributes have to exist before you connect to the source. So you would have to create those attributes in the GIS before you start using that data source in TBC. Project info. This is something that's new at TBC 2025.10. In the TBC project properties, you can define things like reference number, user name, things like that. Those now are transferable into GIS attributes. So if you had, let's say you wanted in all of your layers, you put project reference number or project ID, you can transfer, you can configure it to automatically transfer that property from the TBC project into GIS. For any data that you write from that project will be stamped. That attribute will be populated with that reference number from the TBC project properties, in addition to the user, things like that. There's a handful of properties that can be persisted into the GIS. Media files transfer as attachments. I mentioned that a little bit earlier, around if you have photos, documents, anything that's attached to a feature, those get transferred as well into feature services and geodatabases. Key caveat here, attributes and attachments must already exist in the GIS side, in the schema, before you create the connection, right? There's no functionality in TBC to create that new GIS schema while you're doing this. Okay, summary. Most important things. Understand the workflows that are possible and what you want to use. We talked about 3. You could certainly figure out others, right? There are ways you could, there's more round-tripping workflows that I didn't really cover if you want to have, edits made and applied, things like that. Decide if your TBC or GIS schema is authoritative and make the other one match, right? Don't really do well with disparate schemas. We want schemas the same on both sides. Use standard coordinate systems if possible. Lastly, expect us to continue to improve TBC GIS. This is an active area of development that myself and other product managers are involved in, as well as engineering teams. Okay, Q&A. Albert.
Okay. Thanks, Matt. I see we got a few questions that popped up. I think the first one we'll go into is, does the current Trimble GIS module and connection support advanced Esri SQL functionality like editor tracking, Kogu, etc.?
So in this case, I'll separate this. Editor tracking, yes. If you had innate editor tracking is functionality in ArcGIS that allows you to define, automatically add standard fields to track information on who was the last person to edit that, who created it, when was it edited, when was it created, etc. So if you were to enable editor tracking on these feature services, TBC would see that and say that, hey, these are Esri managed fields. I'm not going to touch those, and they would get populated when that data is written to the feature service. So they're not going to get persisted into the feature code library, which is not what you would want. You would want that to be managed on the Esri side, which it is. So those editor tracking, yes. Utility network, no, not yet. Right now, you cannot edit data in a layer that participates in the utility network, so that's not there. Kogo, Kogo is more of a user experience tool, or in Esri, there's not a lot at the data model level, or there's nothing really at the data model level around Kogo. We do support true curves, which is kind of related. So if your feature service is set to support true curves, we will pass true curves from TBC into the feature service. The other thing I was going to say in this, so this is points, lines, and polygons. So what's not here in the GIS module is surfaces. So surfaces, alignments are not there. You could bring in a polyline from GIS into TBC as an alignment. I didn't show that, but there's a choice, a little pick list. When you connect to a line layer, you can choose whether you want to bring it in as a line or an alignment. So I think that kind of covers at least some of that. All
right. Thanks, Matt. Benjamin just wanted to check, are you working in an enterprise environment for these examples that you showed in the videos?
Okay, so these environments I'm working in, if we're talking about ArcGIS Enterprise, and so these demos I gave were ArcGIS Online. That was easier for me to work with from a demo standpoint, but everything you saw, I could have done against ArcGIS Enterprise. So there's no real difference. A feature service is a feature service, regardless of where it's hosted, in online or enterprise. The only thing that may be different in enterprise is your security posture might be different. You may have, I could have prompted myself, instead of an ArcGIS login, I could have been prompted with some sort of federated login, right, for my domain or Okta or something like that. But this, the only thing I will say on an enterprise standpoint is we don't yet support the versioning at the feature service level. We support versioning at an enterprise database level. We don't yet support versioning defined at the feature service level, but that is something that's definitely on the roadmap.
Question from Nick, I think that you answered. It is a manual process, and the automation is not there for the symbology because it's not the same kind of symbology that matches easily with Arc and TBC. So it is a manual process, and Benjamin, that answer, you can actually bring some DWDs in if you want to with symbology to make them match. But yeah, unfortunately, that is a manual process. So that is something you'll have to manually go and match up, as Matt mentioned a few times. Eric just wanted to know what's the limit of the amount of stuff you can read into TBC through the connection?
Yep. So that limit is actually defined on the feature service defines max records in one go. So as a property of the feature service, you can define that. That's the limit we will use, and we will recursively call to get up to that limit. But if you want to bring in area data for different areas, it's generally recommended to focus on an area at a time. So the limit is generally set by what's defined at the feature service level.
Okay, I see Samantha got some answers already on her ground to grid coordinates. There's a lot of ways that TBC can do that. It's pretty good at doing all that for you, so I'll just skip over that one. If you make any changes to the schema or the feature code library, can you update the GIS connection, or do you have to create a new one?
I can take that one. That's a good question, Eric. I think that in this case, So what I will say is that the system, the workflow does support some ability to have attributes, add attributes to one, right? Let's say I had additional attribution in my ArcGIS side that I added later that I didn't care about in TBC, or that I didn't know at the time, didn't exist at the time I created my feature cut library. Well, when I connect to that feature service, I can bring those changes in. I can bring new attributes in. What it doesn't really work well at is if I change attribution. If I say, well, hey, this data type changed from integer to string, or this pick list changed from these 5 values to a totally different 5 values. That's where it starts to get messy. And it's not set up well to do that right now. The best practice there would be to define it, to make the changes in one side, and then pull it in as new schema. It's like I said, it's not set up well right now. It's to say, hey, well, I want to change this and have that reflected over here. It's better you're going to generally start with a new schema in that case.
Okay. Thanks, Matt. See, we're almost out of time. We'll get these rest of these questions over to Matt. If there's anything specifically I can help you out with, he'll reach out to you. Appreciate it, Matt. If you'll just jump onto the resources, so we just quickly get through that. Just again, for everybody's notice, if you want to get any of the resources, the Geospatial webpage is there in your TBC support tab. You can find all the tutorials, e-learning, these power hours, any and every one that has ever been done will be found under there. This will probably be up in the next few days as well. So use that. The YouTube channel has got great content as well. And then on the community, you can ask fellow users on what you would like to do. The resources PDF right at the bottom, that's a great way of finding anything and everything related to TBC. And then on the next slide, Matt has put up the specific GIS page that we currently have for Trimble Business Center. So there you will find all this information. There's a good amount of content that shows you how this works, how to set up your services, how to connect to them, and anything in there. Matt, anything you want to add on the GIS content?
No, I think the one thing I would say is that, if you're going to be working with feature services, you're not required to really have a deep level of knowledge about ArcGIS, but I think it helps if you are an ArcGIS customer, or if you're supporting an ArcGIS customer. It helps to know something about ArcGIS Online and ArcGIS Enterprise. I showed in a lot of my demos the use of ArcGIS Pro. That's a tool that I'm familiar with. But as far as, I wouldn't need ArcGIS Pro. The only time I really would have needed ArcGIS Pro in the demos that I just gave was for taking that geodatabase XML file, turning it into a file geodatabase, changing the coordinate system, and publishing it as a new feature service. That's really the only part that I could only do in an Esri desktop app. The other stuff around making web maps, discovering feature services, things like that, I could all do through the browser as long as I had access to ArcGIS Online or ArcGIS Enterprise.
Thanks so much. Thanks, Matt. Just the last slide. If you need to reach out, you can contact me. I can always put you in contact with Matt if needed on anything specific. Thank you so much for your time. We appreciate it. Hope you have a good morning, afternoon, and evening, wherever you might be. And then hope to see you in the July-August Power Hour. That will be up in a month from now. Matt, thank you so much for your time. Appreciate it. And have a good day as well.
Thank you. My pleasure. Thank you, everyone.